All right, so up until this point, we've been dealing only with right triangles, and that was a huge stress point. You had to have a right triangle for those formulas to work. Now we're going to get our two tools that work for all triangles. Now, knowing when to use which tool is going to be a matter of recognizing the fill in the blank. Do you have enough information so that you only have one unknown? There's some patterns that you can find, and what's going to happen in some of the more complicated problems, you'll need to use, for example, law of cosines first, and then you can switch to law of sines, or vice versa. So there's a variety of steps to a lot of these problems. You need to be very, very careful with your order of operations and obeying your algebra rules for when you're solving and isolating variables. So let's look at a couple of examples. The law of sines is basically a set of formulas that allow us to set up ratios. And here are your ratios. Now, obviously, we don't solve things with 3 ratios, but you can use any 2 of those ratios to create an equation, cross multiply, and solve. The way this works, if you notice, is that I have the sine of b and its side b, and I have the sine of a and its side a, and I have the sine of c and its side c. And so you set up the angle, sine of the angle, and its side opposite. And it doesn't matter if you have the side on top or the sine of the angle on top. Either way works. So for example, solve the triangle below. Now, key trig. This word, solve, says find all, which is usually 3, missing parts. That is explicit. That is what it means. So if the directions say solve the triangle, it is a 3-point problem. Now you always want to start with what are you given? What are you given? I know this angle and its side opposite. I know this angle. I don't happen to know its side opposite. But knowing angles and side opposite sets me up for the law of sines. So let's start our first step by saying that the sine of 38 over 6 is equal to the sine of 70 over j. Once you have that, sine being a number, it's a simple cross multiply ratio problem. And so I have j sine of 38 equal to 6 sine of 70. Again, notice that I'm very careful about putting that constant term in front of the sine ratio so that when I enter it into my calculator, I don't get confused. I want to isolate j, so I'm going to divide both sides by the sine of 38. That is a number, some decimal that's less than 1. Sine of 38 cancels with sine of 38. This gets put into your calculator. And I will continually stress to be very, very careful with how you enter these things into the calculator. So I usually do the sine first. So these calculators, you do sine 70, and I'm going to hit enter. Times 6, that's my numerator, enter. Now I'm going to divide by the sine of 38. It is perfectly acceptable and often a really good idea to write some of those numbers down as you go, just in case. And so what I find out is that j is equal to 9.16. There's my first piece of information. Now the second thing that I'm missing is k. K is the easiest one because angle k is equal to 180 minus 70 minus 38. Don't forget that even though our problems have gotten more complicated, sometimes triangle sum being 180 always is true. So that's one of your easy ways to solve. And when I do that, I find out that angle k is equal to 72. There's my second value. Now my third missing value happens to be side k. Well, now I know angle k, so I can use the law of sines again. And I'm going to go with h and its side because that was given. And I'm going to say the sine of 38 over 6 is now going to be equal to the sine of 72 over k. All right, once I've set up this ratio for k, again, it's a matter of simply cross multiplying. So I end up with k sine of 38 is equal to 6 sine of 72. Divide both sides by the sine of 38, because again, that behaves like a single number. Be very careful when you go to your calculator. Again, I usually do these in pieces, so I will do something like sine 72 equals times 6 equals divided by the sine of 38 equals, and I end up with k being 9. K is equal to 9.27. If you are getting wildly different, crazy answers, go back and check that your calculator is in degrees and not radians, that it says DEG, not RAD. Okay, now if we go down to the next example here, this one is asking us to find S and T. Now, knowing where to start has to do with what we're given. Obviously, we're given these two, R and its side opposite. So that's where I'm going to start. This side being given here is in relation to S. So that tells me which angle I need to start with. I can't find T yet. I have to find S first. So my first step is to say that the sine of 53 over 5 is equal to the sine of S, which I don't know, over 5.26. Quick cross multiply. And so I have 5 sine of S is equal to 5.26 sine of 53. Now, this time, my variable, my unknown, is S. And now it's linked with its ratio right now. So what I need to do is I need to divide both sides by 5. And so I have the sine of S is equal to 5.26 sine of 53 divided by 5. I'm going to do this division that's on the right and get a decimal. So what I'm going to get is a matter of, if I clear this, I have 53 sine, whoops, wrong calculator, sine 53, enter, times 5.26, enter, divided by 5. Now this gives me this big, long decimal. I'm going to grab 4 digits of that, and that tells me that the sine of S is equal to 0.84. Let's call that good. Now, to find out what the actual measure of S is, I have to undo the ratio. Remember, we undo the ratio with that inverse feature. And that is going to give me what the measure of S actually is. So I'm going to go back to my calculator. These calculators have a cool feature. Actually, the smaller ones do too. I'm going to say second function sine. Notice that little inverse piece. I'm going to do second function answer, and it's going to pull an entire decimal, so I don't have a rounding error, and hit enter. So S is actually equal to 57.2 degrees. Now, to find T, it's a pretty sweet deal, because now I can just do angle sum. And so I know that 180 plus, whoops, 180, sorry, that angle T is equal to 180 minus 53 minus 57.2 by the triangle sum. And I know that angle T is 69.8. That third angle can always be found by subtracting from 180. That's probably the slickest, nicest way to do that. I'm going to put the law of cosines information